Okay, do you hear me? Yeah. Okay, so thank you for being here. First of all, Michael, thank you for your presentation. It was really interesting. As you can see, we are younger, but we are still really keen to this technical stuff. So bear with us. This is our journey from taking the, well, we will be talking about data culture in the industry, and we will be actually talking about our journey from taking the data hole that we found into a whole data that we now have. So, is it working? Yeah. So first of all, who are we? Okay, so we are my name is Alejandro Barredo. This is Aitor Gamarra. We are software engineers in Kurago. Kurago is a software engineering company here in the Basque Country. Kurago conceives, creates, implements, and develops solutions for sheet metal manufacturers. Kurago is 100% owned by Bystronic, by the Bystronic Group, which is a technology company with the area of the sheet metal industry, with extensive history on manufacturing laser cutting devices. Siri is again on. And then Bystronic bought Kurago with the idea of creating the smart factory concept, and this joint vision includes the idea of having the full management of data and material flow from end to end for the sheet metal industry. And another note on that is that this niche industry is one of late adopter of the digitalization. So bear with me with what we found. Okay, so what was the reality when we got there? About 2.5 years ago, well, I think we can agree here of the importance of the data, right? How to handle data, how to use it and transform it. Sorry, I hit it by accident. Yeah. So I think we can agree on that in this room, right? But that is not the same picture across industries. What we found is that when we started, we found that the data quality was poor. We had different displays of the same sources, resulting in different outcomes, which means like huge distrust on end consumers. We also found that how data was handled, transformed, and stored was not standardized. It was really hard to track how that data was being handled. And finally, we also found that for many key subsystems that were like so important to be able to tell the whole story of the data, we didn't even have that data in place, okay? So the other part is that at this point there was already 2 solutions in place, okay? One based or meant to acquire the data from the machines, and the other one was a cloud solution for analytics and displaying. So the first solution, the acquisition part, was deployed in-house on .NET, and its aim was to be able to connect to different devices, gather the data, and send it to the cloud. And then the cloud solution based on Angular, Node, Express.js, and Stream Analytics from Azure was meant to provide value to the end customers by displaying that data. Okay, one of the key problems that we found when we entered here is that this acquisition solution had to be deployed, serviced, updated, you name it, on-premise. So you had to go to the factory, to the in-factory premises to actually update the software or troubleshoot the software, and that is a pain, and you know that. So at this time is where the first Kurago team starts working on this project, and the first question that we had to answer ourselves was, do we scratch everything and start from the beginning, or do we start working on what we have and evolving it? And at that time, the solution was to actually evolve that solution. On the one hand, we had the acquisition part, which at most we were able to resolve bugs, troubleshoot, and try to keep the roof. And on the other side, we had the in-cloud solution for analytics that we started working on and developing. and we mainly focused on improving the performance of this whole solution, creating the different ETLs and CI/CD to be able to deploy the resources in a programmatical way. We were also trying to modify our look of the data instead of having instead of trying to just give value to the end user, which was the actual customer that was consuming the analytics. We were trying to think of how to lift that value of the data, not only for the end customer, but end-to-end throughout the whole process, and be able to service ourselves as a company and also the clients to give back that value to them. So at this point, at that moment in time, when we started developing, we found out that the solutions were very different, and we had different maturity levels in both solutions. That meant that on the one part, we had the solution, the in-cloud solution analytics software, in which kind of we had the idea of what we wanted for the future, right? We wanted in-house developed solution that was able to store, analyze, transform the data, and be able to run analytics against the data, and then display them to end customer and also to in-house customers. But for the other part, for the acquisition part, the idea was not so steady, let's say, because we had to find how to go from what we got, which was an acquisition system that was just meant to connect to a couple of devices and send the data upwards, into something much more dynamic, much more flexible, that had to be able to connect to different devices, different manufacturers of devices, different types of data, different sampling rates, different protocols, different everything different. We had to be able also to work on how to deploy, service, upgrade, install, all those things. We had to, without having to send operators to the factories, because that's a great leap in time, right? So that is the time in which we had to develop these situations in two teams separately. One was the A team, as you can see on the screen, which had the right idea and was more of evolving what we knew. And the other one had a much more R&D, research and development aspect to it, because we had to find out what to do. So, and that was the two routes that we came to know, and this is what Aitor will continue with.
All right, thank you, Alejandro, and hello, everyone. So yeah, the situation at that point in time, we had two teams, Team A, Team B, and we like to call this the insights era for the A team. Here we're talking about good practices, because we find out that all of the solutions were kind of put together as they were, but nobody really thought about CI/CD, DevOps, how are we going to deploy this, how are we going to integrate our ETLs with our database schema changes, all those stuff. We had to make a really good solution so that we could grow our platform and build a really robust product. And then there was the visualization side of things. We had really static visualizations, and Alejandro was too polite to say, but the previous solution was kind of ugly. So yeah, we now have dynamic visualizations so that we can really show the data that we want to show. Then the B team, the acquisition and development. This was a pure R&D team. That's really exciting and quite a headache. We had to run a lot of proof of concepts. Why? Because we had to connect to our machines the same way that we were doing before. We had to choose the protocols because we saw that maybe the way we were doing that was not the best. We had to design schemas and structures. Quite a plan. It sounds really easy. On paper it works. Then you go to the machine and everything breaks. Why? Because the reality for us at that time was that the machine data that we were gathering was like looking at the machine from the outside. And then we decided to go inside the machine. A machine is a collection of subsystems, and each of the subsystems has a different data that we can exploit. And then there was quite an uncertainty of what could be done, because we have all this new data, quite the volume of data, and we really don't know what to do with it. We know that we can do something, we can check the differences between the subsystems, what's the real picture that we want to paint, but for us it was new. So we had to run a lot of proof of concepts, and trust me, we ran them. And we need to iterate fast. A solution built in .NET, it's static. So we need something that allowed us to iterate fast. Here's where tools like Nifi or Node-RED come into place, so that we could try a lot of different protocols, we could try a lot of different acquisitions resources, and yeah, it really helped us run all the proof of concepts that we had to run. And another problem we found is that in our company there was no data culture. That happens across all the industry, apparently, because this is not like finance where everything is tracked. Here everything just makes their data, maybe if you're lucky, somebody maybe consumes it, and that's it. There are data silos, or as our unit manager likes to say, the data is kidnapped. So yeah, there was a lot of talking to be done. And here we reach a place where a phrase that one of our Swiss colleagues usually tells comes into mind, like, what's the story we want to tell? Because we had this team that was able to process the data, was able to build these amazing visualizations. Trust me, the difference between the old one and the new one is really exciting. And then we had this other team that reached a maturity level with the data acquisition solution that was good enough for all the things that we wanted to do. So it was getting harder to align all the backlogs, all the sprints, you know the drill, between both teams, because their job was intertwined. Like if I'm building an acquisition solution and I'm sending that data to the cloud, the other team has to be able to get that data, process that data, present that data. So we decided to merge the teams. And actually, a lot of opportunities opened here because we were able to iterate fast. All of the things were happening at the same time. Everyone was aligned all the time, so it was really, really great for us. And the solution that we built for the data acquisition was called the data platform. You have heard the name everywhere, but for us it's the data platform. And this meant that there was a new approach in the organization, because as Alejandro said before, previously the data we were using was just showing the client a couple of data points from the machines, and that was it. But then we were talking to the stakeholders and the different data producers, and we thought we can do more things with data. Like we have our machine R&D teams, they want to know how their machines are performing. We have our solutions teams, our support team, they have to know how all our systems are interacting and everything. So there was a new perspective for everyone, because suddenly it was not something that happens in the background and maybe you see some graph and you're happy. It was a system that could provide value both for the clients and for our company. So yeah, one of the issues that we have here is that stakeholders like to ask things. And sometimes a new line, a new data point sounds super easy and actually means that we have to adapt our architecture to be able to gather those data points, process those data points, present those data points. So there was a mentality shift in our company, and we're quite happy about that, because it took a lot of talking to a lot of teams, but now we're in a place where everyone kind of thinks about data before just putting it on an interface and forgetting about it. So we started a new era of data-centric development. Here's where I'm talking specifics. So, for example, we have Databricks, which is great because you can do anything, which is not great because you have to do anything. And we use the Azure infrastructure for this. We use IoT hubs for acquisition. We use blob storage, which you know the drill. But it was great because we had to think about the architecture to adapt to all those data points that I talked before. But this time it was a solution that was thought before it was deployed, so great. Then our data, I mentioned before that we had a really high data volume, and that's because we were gathering data from the subsystems. These subsystems work fast. We're talking about laser cutting, so that's a lot of data per second, and we had to store it somewhere, and we found out that the SQL solution was not good enough. And here's where timescale DB comes into place, and if you have seen their database as a solution, pricing it's expensive as feature pack. So we had our amazing DevOps team. Here they came to the rescue, and we now have a high availability timescale DB deployed on a Kubernetes cluster, and we're really happy because when we were running the tests, we had like a 10 to 100 increase in the performance, in the read performance. So being able to use that was really special for us, and they made it possible, so thank you. And then the data lake, I will come back into this, but the data lake also was part of this mentality shift that I was talking about. Then Node-RED. We liked Node-RED that much when we were running the proof of concept that is now part of the building blocks of our new data platform. And this meant that we are now able to gather a lot of protocols. We like OPC-UA, for example, in the open interfaces in the factories, but that's not the reality everywhere. You have to deal with protocols like ADS or S7, depending on your PLCs and everything. And then NAT. I have to say this phrase, I'm sorry, I promised a colleague. NAT is NAT, and it was for us. Because we're not talking about data going from A to B, like from this machine to this program, from this program to this machine. The reality of the factory is that it's alive. There are a lot of systems, they are connected, and we need a single source of truth. And here's where NAT came to the rescue. We have a pub subsystem, but it's working on the factory. So all of our programs, like the real-time visualizations, the machines, our data platform, everyone can connect to this broker, and we are able to finally paint the whole picture of the factory. And then the visualization. I mentioned that we now have beautiful visualization. That's thanks to eCharts, Apache eCharts, thanks Apache. We were able to use that library, and here we're talking about eCharts. The open source idea comes into place. As you've seen here, there are a lot of open source stuff, right? And that was hard at first for the company because we're talking about a company that is really happy buying third-party libraries, compiled DLLs. Nobody knows what's going on inside black box DLLs. And when you are doing data acquisition, sometimes it's really hard to know what's going on. Like, is this a network issue? Is this a protocol issue? Is this a machine issue? What's going on? So being able to go into the code of the libraries that we were using, for us, it was really important. And we were able to open issues. We were able to open PRs. Some of them emerged. We are just starting our open source journey, but I'm quite excited, and the team is quite excited because we come from backgrounds where open source was really important, and we are now able to put that into place. And then, of course, the future. There are still many issues to solve. There are new machines, there are new subsystems, there are new protocols, a lot of stuff to be supported. And that's exciting, but of course, again, that's a headache. The systems vary a lot. So we have to talk to a lot of people, which is also an important part of the job that sometimes gets overlooked. But we're happy because we have a solid foundation and we are really well prepared because there's a new data point, there's a new system, there's a new machine. We now have the infrastructure to be able to acquire that, to process that, to store that. And then I talked about the data lake before. Why is that great? Because since now we're talking about providing value to the company with data, a data lake is essential because we have all the data available for us, all the detailed data, not like on our databases where you purge the data because otherwise your web page just dies. So we are now able to do interesting stuff with data. Analytics. This is where the buzzwords come in. All the machine learning, artificial intelligence, training models, you name it. We're able to do that. Why? Because we now have good data to do that. We now are sure that the data we are storing, and that's a lot, trust me, is useful. And we can trust it, because before, maybe the machine was cutting, and the interfaces were saying something like waiting. And the other day we were talking about this, and like 2 years ago, when exploring the interfaces, one of them went like, the machine's waiting, but what's it waiting for? It's cutting. So now we know that when the machine is cutting, it's actually cutting. So good data, that's really important for analytics journey. And of course, we have a really great team. Alejandro here has a PhD in artificial intelligence, so, you know, I know, so young and so well prepared. So now we're in a place where we can do that. And it's really exciting looking back, because when we started, it was a data hole, hence the title. And you see how far we've come, and it's really great, and it's really exciting for us.
Okay, so to summarize, we we talked about our journey that began with a reality that was not what we wanted. What we wanted is what Aitor has mentioned, right? So we came from a place in which data was something that just was meant to show to the client instead of getting value from it and being able to exploit it. And now we've come to a place in which we have built that system that, of course, has many things that have to upgrade and improve, of course. But we have that foundation in place in which we have the grounds to be able to run models, to be flexible enough to change, because we will have to change, and to build up for the future. And I wanted to stress a couple of things that we found during this journey. The first one is that on paper it's really easy to plan for the future, right? You plan the architecture, you plan the technologies that you want, you plan how everything is going to look, but flexibility is key. In real life, you plan something, and more often than not, it won't come as you want it. So you had to be flexible enough, and our solution is meant like strictly on being able to adapt to different technologies and different ways to use data and transform data. The other one is that we are in an industry in which two worlds collide, completely different worlds. We have one that is the sheet metal machine manufacturing, with life cycles of maybe a year for the improvement of devices, the improvement of protocols, and all that stuff. And alongside it, we have our world, in which we have 3 weeks sprints, in which we can improve our software with every sprint. How to merge those two worlds is a really difficult task to overcome, and we're working on it. And the third one is that data culture, I think we can agree here on the value of data, but that is not the same across industries. And being able to evangelize of the value that the data has, not only for customers, but for the industries themselves, to be able to improve their processes, to optimize their workflow, and to learn more about their own industry that they so much know about. It's a hard task at the beginning, but it's really fruitful task, because when you have people in your team, as we now have, you actually have a company that can build the future. And finally, just to leave a last note, the people involved is what is most important for the solutions, right? You can see here a Gen Z, a millennial. We have boomers in our team. We have every type of people. And that is key, because whatever we build is built by people. And I wanted to leave you with that. Thank you, everyone. This was our presentation, and we will be welcoming any question. Thank you.
Very, very good. Any questions? I have a question.
Go ahead.
Particularly because you mentioned that last point, which I really, really like. It's one thing we're talking about technology, but at the end of the day, it's going to be in the hands of people.
Yeah, sure.
And so nowadays, when we talk about data, is it something that's exclusively siloed to the data team, or to what extent does everybody become a data stakeholder? And that can be from a storage perspective, it can be from a, which we'll talk about later on, a data protection, privacy compliance perspective. In Kurago, how do you create a culture of knowledge sharing around data so that people like Ari can also share their voice as well? No, but I really mean it. Like, how does that work? How do you get everybody up to speed? Because a lot of these things are moving very quickly, and it can be tough for people to understand. So how do you do that?
Well, I would say that maybe it sounds simple, but it's not, and that is communication, first of all. So I think one of the greatest burdens that we have when we talk about data, about new technologies and stuff, is that we don't communicate enough. And in this case, like workshops, being close to people that actually has the knowledge on the, let's say, the machine stuff, and who actually know their stuff on the engineering side, that communication is key to be able to break those barriers and make everyone accountable and become a stakeholder of the data itself.
Very, very good. I like that. And not from a position of this is overwhelming, this is really complex, I'm just not going to be interested. But actually bringing people and inviting them to those conversations. Something that I looked at a lot as well too, you know, if we can't explain these concepts to a child or our neighbor or a grandparent, you know, can we really actually do them in our day-to-day? So I think that's a great point. I want to know a little bit more in terms of when deciding which technologies you're going to be using. How does that process work in Kurago?
All right, so easy example, timescale DB. We just found that the current solutions weren't enough, like we aren't able to read the data at the speeds that we want so that the web page isn't cluttered. So what we did there was we had like 5 identified solutions. So our architects team, they're really great, thanks architects, they did an easy pro-con list. And they decided on a couple of solutions that were good enough on paper, and then ran the tests. And when I'm saying that we had a 10 to 100 increase in read performance, I'm talking real data. Like we downloaded, I think it was 40,000 Parquet files or something like that. They loaded that on the databases and they tried to read the stuff in the same way that we were going to do in the future. So it was as real as possible. And then the numbers talk for us. Like, if you get a really, really high performance, that's it. We are a very data-driven company, and that means also that when we make decisions, they are data-backed. So it was like that.
Very, very good. Great to hear from that. It was actually, it was last year in KubeCon in Detroit that someone from Kurago, Ellie, also gave a talk about running MongoDB and Kubernetes. But it's just interesting to see, from the end user perspective, you have a lot of solutions out there. You only have a certain amount of time to be able to test them out. How is it that you go about finding those results? Very nice answer. Thank you very much for your talk. Much appreciated. Let's give them a round of applause. Very, very nice hearing from both of you.